Hey, it's Dr. Gold. We're rolling along here up to chapter 6. Now, up to this point, especially in the last chapter, we were dealing with future value and present value calculations. And the one thing that was constant in both of those calculations is we were taking one whole dollar amount in the present and then figuring out how much that money would be worth in the future based upon a certain rate of interest. We also went out into the future and said, well, what if in 5 years from now this dollar amount existed? How much would that dollar amount be worth in today's dollars or present dollars? So we did both calculations that way, but it was one single cash outflow at the beginning of the process. Here in this chapter, we begin to explore annuities and doing future and present value calculations for annuities. And annuities differ in respect to just general present and future value calculations, because now we're not just making one single payment, but we're making a series of equal dollar payments that are made at equal points in time, such as every month or the end of every month, the end of every year, at the end of every quarter. So for example, a mortgage payment is an annuity from the perspective of the bank, right? From the perspective of our lives, it's just a payment you're making. But from the bank's perspective, it's a payment that's coming in, or a cash flow that's coming in every month as we pay the mortgage. Now, it's important to note as we start out here that payments for annuities can be made at the beginning or end of each period, let's say each month, each year, whatever the case might be. And when payments are made at the end of a period, that's referred to as an ordinary annuity. There are times when we don't make payments at the end of a period, at the end of the month, like for example our rent payments. We make rent payments typically at the beginning of the month. And we'll talk about like a little nuanced difference in the calculations of future and present values of annuities when we get to that point where the payments are made at the beginning. But for now, as we move forward, assume that the payments are being made at the end of each particular period. So here's a question from the textbook, and it reads as follows. Let's assume that you're saving money to go to graduate school. You've taken your first job and you plan to save $5,000 each year for the next 5 years for your grad school fund. You're going to earn 6%. How much money will you accumulate by the end of year 5? So let's think about what's happening here. Well, first of all, at point 0 here, which is the present, we'd have no money in the bank, nothing saved for graduate school. We just got a job, we work really hard during period 1, and at the end of period 1, we make our first deposit into this magical fund that's earning 6%. Now, if you were just doing a future value calculation for that, you would look here and you would see that the future value of $5,000, and how many times is it going to compound? Well, it's going to compound 1 time, 2 times, 3 times, whoops, and then 4 times. Okay, not 5 times, because you're making the payment at the end of the month, so at the end of the year rather. So during this period here, you're not earning any interest. You will earn interest there, there, and there. So when you do that calculation 4 times, you end up with a future value of $5,000 equal to $6,312 because it compounds for those 4 periods. Then at the end of year 2, you make another bank deposit for $5,000. And then that one compounds for how many periods? Well, 1, 2, 3 periods, and that amount will come out to $5,955. And you do that with the additional payments in years 3, 4, and then you'll notice here in year 5 you don't make any money off of that because you're making that $5,000 payment at the end of year 5, and that's the end of the line for this savings plan. So you then add up all of that amount of money and you'd have $28,185.46. Obviously, how much have you actually saved in nominal dollars? Well, you had $5,000 here, 5,000 here, and so forth. So it's 5, 10, 15, 20, $25,000 you came up with. And at the end of that rainbow, $28,195.46 has been accumulated at 6%. So that's sort of the timeline perspective of a future value of an annuity. And you can pause the video, rewind it, review this for your own practice until it becomes crystal clear, because it's a little bit tricky here. We're not really earning any interest here during this period from 0 to 1, whereas in the previous chapter we were earning, because we started out with a certain amount in the bank at point 0. Here we had nothing in the bank. We didn't put anything in the bank at point 0. We had to wait a year of working at our new job to save the $5,000 in order to make that deposit. Now, you still, when you're doing this, need to write out the 5 criteria. What we're really solving when we solve for annuity questions, in most instances, is the payment amount. What is the actual amount that we'll be making? This is like a new introduction into the picture. So here, the present value we know was 0. We had no money. The future value is what we're trying to figure out. The interest rate is 6%, as stated in the question. Now, the payment amount, which we hadn't to this point dealt with, at least on our calculator until right now, is punched in at minus 5,000. Now, why is it minus 5,000? Again, you should know the answer to this, so maybe you want to pause the video and think about the answer to why it's minus 5,000. But in the world of finance, everything revolves around cash flows. So the question is, the $5,000 that we've saved up over the first year of working, when we deposit it into this account to earn 6%, that's considered a cash outflow from our life into the bank. Therefore, it's a negative amount. And then, of course, the number of periods here is 5. Another way of looking at this is by looking at this table here, which kind of helps to clarify some things. At the end of the first year, we make a deposit of $5,000. It will compound for 4 periods, and as we illustrated on the previous timeline graph, it will equal that amount. At the end of the second year, and I'm emphasizing the end because that's kind of a differentiator here, we then compound for 3 periods. How do I know it's 3 periods? Well, the deposit's made at the end here, and we've got 1 period, 2 periods, 3 periods for us to make money off of payment number 2. And you move along down the line that way, ending with your final payment at the end of the 5th year, where it doesn't have any time to compound at all because the annuity ends at that point, and you have your total there that we discussed in the last few slides. This is the math formula behind it. It's really not very complicated when you sort of break it down, so let's kind of do that. The essence of the annuity future value formula is right here in the middle. It's basically saying the future value of an annuity equals the payment dollar amount, in this case $5,000, and then you have to solve for this factor here, which is 1 plus the rate of interest, which is 6%, to the number of periods, 5, minus 1 over the rate of interest. So why don't we just do that really quickly on an actual calculator? The answer is here, the factor, but let me just show you how to do it if you wanted to do it manually. So you would take, to solve again for this factor, 1.06 to the 5th power, and that equals 1.3382. Then you do minus 1, and that equals 0.3382. And then you divide that by I, the interest rate, or 6%, and 6% expressed in decimals is 0.06. and you hit equals, and you get a 5.63709, which is the same thing as this factor here. You then would multiply that by the payment amount, and when you multiply this by the payment amount, you get the answer to the question. So that's sort of the math formula behind it. Of course, once you kind of get that seared into your brain and you understand how to solve the future value of an annuity question using your brain and being able to actually do the math the long way, because oftentimes, you may not have a financial calculator at the ready. You may want to also just be able to sort of visualize the variables that go into calculating things that a calculator magically can calculate. But in the end, when you're taking exams and in the real world, most of the time you're going to have access to either Microsoft Excel or a financial calculator. And this will be the process for answering this question as well. For n, you'll put 5 periods here. Even though you're not making money for 5 periods on the $5,000, it's a 5-period long process, because in the end, the 5th final period, there's no interest being earned on that money. The interest rate is 6%. The present value is 0. Again, minus 5,000 for the annual payments because it's a cash outflow, and then you solve for future value to get to our answer. So that is the tutorial, at least from my perspective, on solving for the future value of an annuity. In the next video, we'll do the same thing except solve for the present value of an annuity. And again, the main difference between this chapter and the previous chapter is the introduction of payments. Okay, before we didn't have payments involved, like regular set payments every year. And the reason this is kind of exciting and interesting, at least to me, is because this begins to mirror more closely with real life. Very rarely do we just have a lump sum of money that we just throw into the bank and say, okay, let it ride for 45 years at 10%, which is what a future value calculation would be. Normally, we start out with very little money, if at all, and then make regular payments each year into a retirement account or a savings account. And over a long period of time, those payments, in conjunction with the magic of compounding, add up to a large amount of wealth being accumulated. And that's really why future value of an annuity calculations begin to take us one step closer to reality. So I like sort of touching upon reality from time to time. And in this chapter, at least, we begin that process.